everyone, my name is Vaishnavi Telrande and we are going to study VI characteristics of PN junction diode. So let's get started. First we will discuss the diode specifications. The diode we use is 1N4007. This is the standard recovery type of diode and it has repetitive reverse voltage 1 kV. Repetitive reverse voltage is the maximum voltage a diode can withstand in reverse bias direction before breakdown. Forward current is the average amount of current a diode is able to conduct in forward bias mode. It is 1 ampere. Forward voltage is usually specified at diode's rated forward amount of current and it is 1.1 volt. Reverse recovery time is the amount of time diode takes to turn off when the voltage across it alternates from forward bias to reverse bias polarity. Ideally it is 0, but practically it is in the range of tens of microseconds, or for some diodes it is nanoseconds also. Forward surge current is maximum peak amount of current the diode is able to conduct in forward bias mode. It depends on the thermal capacity of the diode and it is 30 ampere. Operating temperature is also called as junction temperature and it is the maximum allowable temperature for the diode at PN junction. It has range minus 65 degrees Celsius to 150 degrees Celsius. The diode case style of this diode 1N4007 diode is diode outline number 41 and it has two number of pins, that is one is anode and one is cathode. These are the circuit diagram we will be using in this experiment. This is a forward bias circuit diagram and this is reverse bias circuit diagram. These are the observations we have calculated by using experimentation with diode and at NVIS 6501. Here we are varying the voltage and the current is dependent on the voltage. So variable is voltage. This is the graph for the ideal silicon diode. This shows that at 0.7 volts there is a sudden increase in current. This is due to the breakdown voltage of silicon diode is 0.7 volts, whereas it is 0.3 volt for germanium. This is reverse characteristics of silicon diode. Now we will discuss the types of resistances. There are three types of resistances: static resistance, that is DC resistance; second is dynamic resistance, that is AC resistance; and third is average resistance. Static resistance is simply calculated by using Ohm's law, that is V is equals to IR, so I is equals to V by I. Dynamic resistance is the difference del V by del I, that is difference of voltage upon difference of current. Here the value which we will using for calculating the difference in voltage and difference in current should have the less difference, that is they should be the value should be constant, so that our answers will be accurate. Now we will discuss the third type of resistance, that is average resistance. Average resistance is calculated by 1 by slope. First we will calculate the slope of the graph by using formula y2 minus y1 upon x2 minus x1, and then R average is equals to 1 by slope, that is inverse of slope, and we will get the average resistance in forward bias condition. Similarly, this is average resistance in reverse bias condition. So we can conclude that a PN junction diode conducts current only in forward bias condition. The breakdown voltage of PN junction diode in forward bias condition for silicon is 0.7 volt and for germanium it is 0.3 volt. Forward bias resistance is lower than reverse bias resistance, and in forward bias condition the starting current is 0, that is resistance is infinite. This is because unless we reach the 0.7 volt, the current will the diode will not carry current, and as soon as we reach 0.7 volt, that is breakdown voltage, the PN junction diode will start carrying current. Thank you.